All right, so with the mean value theorem, again, we're going to be looking at it and the average value theorem to see what's the difference. So let me go through these pieces of the formula one last time when we're going to look at a second example. But this integration problem stands for the area. We might even want to write a couple of things on our picture. This stands for the area of your problem. So like I just said a minute ago, if you have a problem like this, between 1 and 4, it's all this area right up to there. This f of c represents the rectangle that would go part of the way up that area. And this is from A to B, so your C would be somewhere in here for how high do you need to go on that curve. And then B minus A represents the distance here for the width. So you're trying to figure out what's the height got to be so that you can take this piece and stick it in the blank hole here to make it average out, to fill in the whole rectangle. So it's not a real complicated process. It's just remembering the formula. And average, we're going to look at average value also, and it's just slightly different from this. So let's look at number 2. Okay, so f of x is 2 secant squared of x from negative pi over 4 to positive pi over 4. So again, when you're working one of these questions, it doesn't always help, by the way, to have a visual. Sometimes it does. From negative pi over 4 to positive pi over 4 for secant squared of this formula, I don't know what it would look like. So I'm going to try to do this one without a picture, because the picture's not that important. It's the math that's important. But if you need to see the visual when you're done, to see if it makes sense, you could always graph it to see if that value that you picked for C looks like it would hit the curve and the two little pieces would make a rectangle that's right. But it's more important that you can set it up with the negative value at the bottom and the positive value at the top from A to B. Your formula, which we're very familiar with the derivative in there, is equal to your formula with a C value, because that's what you're trying to find, is the value of C that makes that rectangle the right height, and your B minus your A value in a parentheses next to it. Now, my suggestion again is to work the whole left side out to get your value with the first fundamental theorem of calculus. So what does secant squared integrate to? Whose derivative, who do you take the derivative of to get secant squared? That's right. So it's going to be 2 tangent of x from negative pi over 4 to positive pi over 4. And that's how you need to think of integration. You need to think of who did you take the derivative of to get this? And then look at it and say, now is the derivative of that really 2 secant squared of x? Because if it wasn't, it might be obvious it's going the other way. Now, we got to put in pi over 4 first because it's the function at B minus the function at A. Now, what is the tangent at pi over 4? Remember, tangent's here in the middle. Right, because it's y over x, and y over x when they're both the same number when they're fourths. So it's going to be 2 times 1. And then what would it be down here at negative pi over 4? Considering that it's the square root of 2 over 2 and negative square root of 2 over 2. That's right. That's the only difference between being quadrant 1 and quadrant 4 is it going to be positive or negative? And this one's going to be negative 1. So that's going to be 2 plus 2, which is 4. So now that I've got the answer to that whole side, this is the area of the whole entire integration. What we're trying to do is find out what value of C will have this area and get that little piece of the graph that's hanging outside our rectangle if our length times our width is the other side. So let's work on that side. So we got 2 secant squared of C, and we're going to multiply that by, well, what's a fourth plus a fourth? Because 2 negatives cancel out. A half. So now we've got that side worked out that we can bring it down here and say 4 equals 2 secant squared of C times pi over 2. Now to work this question, this is not factoring. This is solving. So wouldn't it be nice if those 2's canceled out? Okay. So I have 4 equals secant squared of C, and I'm going to put that pi in front of it because it's like a number. Pi is a number, it's not a letter. So we can divide by it. Everybody agree? If something's multiplied, wouldn't you divide by it? Okay. When you take the square root of something, if you wanted to get rid of a square, does that make sense to you also? Everybody agree? All right, so that makes it the square root of, well, actually, the square root of 4 is 2 over the square root of pi is equal to secant of C. Now, does anybody remember, how do you figure out what angle the secant would be this when it's not something off the unit circle, obviously? We'll use the button on our calculator. We do the inverse secant button and get a decimal. And because we took a square root, y'all, what else do we have to recognize that we should be doing? What do you always do when you have a square root? Well, we could, but that wasn't what I was thinking about, because since we're going to use the calculator, we won't need to rationalize it. But if I was doing it by hand, yes, I'd rationalize it, but I'm not going to. No, we need plus or minus. So first, you're going to put this problem in and go secant inverse of 2 over the square root of pi is a positive. Then you're going to bring it back up and stick a negative on that 2 and work it out, because it could be positive or negative. And we don't know which one it is, because that's going to fit in our interval, that is.
Do we have that on?
You're going to have to use your 89 if you want to use secant. If you go to secant, if you go to math under trig, or you can go to catalog and look for secant inverse. I can't do it on mine because the 84s do it weird. Well, I guess it's not really all that weird. I have to do cosine inverse of the square root of pi over 2 and put my plus or minus on it if I want to do it on my calculator. But if y'all do it with the other one, you can do it the way it is.
0.48166.
Anybody else getting that? All right. .481, round off to one more place.
0.4817.
Yeah, I got that.
You got that? Okay. Now, it's down there at the bottom, so you should be able to just insert a negative on the 2 so we can see what the negative one is.
That plus.
That was the plus answer. So now we got to put a negative on the 2 and work out the other one.
2.64. I guess it'll be 2.66 because it's 2.6599. Or no, I guess that'd be
Wait a minute, what's that last 9 got after it?
3.
3 doesn't make 9 go up. Right? Everybody agree? 3 doesn't make a 9 go up? Okay. How am I going to know that these are in my interval from negative pi over 4 to positive pi over 4? Well, first of all, neither one of them is negative. So I guess I'm really thinking about, is it between 0 and pi over 4? Right? What would we need to know in order to be able to know if both of these are in our interval? Yeah, that's right, the decimal for pi over 4. Okay, if it's 0.7 something, then I guess we're throwing 2 point something away because he's too big. Okay. Now, there are occasions in which you may run into the situation that you might not know how to solve something, but you know how to get it all set up. If you get to a point where you've got an equation that you have set up, and even if you could simplify it, like I canceled those two 2's or divided or multiplied something to the other side, if you get to the end and you don't know a way to set it up, at least you could use your solver button on your calculator to solve it if you don't know a way to solve it by hand. Okay? Let's look at one more of this before we look at average. And this one, I'm not so sure about the solving process. We'll have to see if it's something in our repertoire because I can't read all my writing to know what I did to solve it was something we all know how to do by hand. It might be, it might not be. So, we've got x minus 2 square roots of x. Well, we do know how to integrate that, right? Mm-hmm. So that's not going to be a problem. It might be the solving part that might be a little iffy. So if we integrate it from 0 to 2, x minus 2 square roots of x dx, that'll find our area. And then if we put our function over here with c's in it, times 2 minus 0, which we know is 2, maybe we'll be able to divide that 2 out if we get a nice number that's divisible by 2. That would be nice. Don't think so, but okay, it might be nice. I don't think it's going to do that, though, because we got radicals. But we might have some nice numbers. I don't know. We'll see. All right, so what does x become when you integrate it? No, x. Linear. All right, so 1/2 x squared, or x squared over 2. All right, what does the square root over here become when you integrate it if you add 1 to the power and put the power flipped in front? Without the 2. 2/3 x to the 3/2. Is that what you're saying?
Yeah.
Okay. So I could put those two 2's together and that would be 4, right? That might make it look a little easier to work with. 4/3. I don't know if anything's going to make it look easy to work with. We'll just put it in and see. So 1/2 times 2 squared minus 4/3 times 2 to the 3/2 power minus, what happens when you put 0 in there? Think it through.
It just did 0.
It's 0 because 0 times anything's 0 and 0 minus 0 is 0. Okay. So instead of wasting time putting a 0 in there, think the math through. Is there going to be anything left if you put 0 in there? If not, just write 0. So 2 squared is 4 times 1/2 is 2. Well, that part was easy. 2 cubed is 8, and there's no square root to 8. And that's a problem.
Is that how you do that?
Mm-hmm. Okay, well, let's come over to the side. Square root of 2 to the 3rd. That's what it means. To be 3/2 power means the square root of 2 to the 3rd. That's the square root of 8. Doesn't that tree? Into 4 times 2, or 2 square roots of 2. Everybody agree? Well, if I multiply 2 square roots of 2 times this, then I'm going to get 2 minus 8/3 square root of 2 on top. Yeah, I think this might be one we have to do the calculator, because I don't know that we're going to be able to work the whole problem out by hand, but we'll see. Maybe we can. So now we have c minus 2 square root of c, and 2 minus 0 is 2, right? Can I do something with that 2 on the outside that might make the other side look more simplified? Because if not, I'm going to run into the situation of, I don't know what to do with it. Can I divide these by 2? Yeah. You can divide 2 by 2 and get 1, and 8 divided by 2 is going to put a 4 on the top. Because when you divide by 2, it divides into the top. Now, I want you to think this through. This is a constant. It looks complicated, but it's a constant. If I move it to the other side, that's not going to be something I can solve by hand, is it? It should have been. But we don't have that skill. We've never learned how to solve a problem that has a radical and a linear term. We usually just have the radical so we can square and get rid of the radical, right? This would take completing the square to do by hand. You've not been taught that. So we're going to do it on the calculator because you've not been taught that in the past. It's not something that a lot of people teach. So you're just going to put this in while solver under F2. It'd be easier if you type an X instead of a C. But you're just going to put it in solver and see what we can get. And we're looking for a decimal. So you need to put a decimal point on one of these numbers so it will give us a decimal answer and not some crazy square root something. Because the answer to this problem is 1 plus or minus. A huge square root with 6 plus 4 squared is 2 over 3. And nobody wants that. And squared. I don't want to square that either. That sounds nasty. So make sure you put a decimal point somewhere in the question. But you're using the solver button to type this in because we could do it by hand, but I don't have a long period of time to show you something that you've never been taught for today. Yes. Yes, you should be getting 2 answers because it's that plus or minus thing. If I took and dealt with that square root, there's a plus or minus somewhere in there. All right. I have 2 decimals. I got 0.4380. Did anybody get that one?
Yeah.
All right. Is that in our interval from 0 to 2? Okay. I got 1.7908. That also is in our interval from 0 to 2. So in this problem, there are 2 different places that I could place that center of that rectangle thought to where the little piece outside the rectangle would fill in the little piece on the inside. Problem is I couldn't draw the picture good enough to save my neck to make it just where I could show it to you. I probably could put it on the calculator, but I couldn't do it by hand because it's just too complicated of a graph. Now, the last thing I want to show y'all today, yep, that's probably all I'm going to have time for, and we'll probably only look at 2 examples of this one, is average value function. When you work with an average, now, let's just think for a minute. When you average numbers, what do? Okay, you add them together and divide. All right. Do you know what integration does? It adds an infinite number of rectangles together that fit under that curve so it'll be perfect and everything's colored in. That's what integration does, is that it adds all that together. So to do average value of a function, they took that b minus a and stuck it over here so we'd have something to divide by. So there's only one small difference in the formula. The b minus a that was on the other end for the width comes over here and gets divided into the problem so that we can divide the width into the problem and figure out, how do I say that, what the length or what the height of my rectangle needs to be. Think that through. If this was my width, right? And the value of C plugged into my function represents the height of my function, then this is going to give me, when I integrate this side and multiply it by this fraction, it is actually going to give me the width, the length of my rectangle up and down, or what we call height of my function. And that makes it average instead of mean. And unfortunately, in our mind, those two words mean the same thing, and they don't in calculus. Because mean, in this particular situation, doesn't mean add them up and divide by how many you got. Average does. So I'm going to add up all the area, and I'm going to divide it by the width, and that's going to tell me F of C is the length. Okay? So all you got to remember is, if you're going to, don't you always divide by something to find the average?
Yeah.
Okay, that's all you got to remember. And just remember to put that one parentheses over here, and you're good. So let's look at an example. And I picked a really easy one to work. And I can even graph this one. 1, 2, 3, 4. All right. So in this problem, we're going to come back to this illustration in a minute. But if I didn't have that 1 over b minus a in front of my integration, then the integration itself stands for all this area in here. Okay? When I introduce the width, then I'm saying this triangle will fit there, and this triangle will fit in that one. You with me?
Yeah.
So I'm trying to figure out, if you multiply this reciprocal, which stands for the width, if I divide the width into the sum, it's going to tell me how tall does that have to be. Okay? So 1 over 2 minus negative 2, integrated from negative 2 to 2, 4 minus x squared in parentheses dx. Let's focus on that first. We're going to work that whole side out, and when we get done working that side, we're going to set it equal to the original problem with a c in it, and we're going to talk about what those pieces again mean. All right. So 1 over 2 minus negative 2 is just 1 over 4, right? Everybody agree with that? Okay. So we're going to integrate from negative 2 to positive 2. Well, hold on. I meant to write the other symbol. From negative 2 to positive 2. So I'm going to go ahead and write my brackets, and I'm going to fill my function in already integrated. So what does 4 become if it's already a constant?
4x.
4x. And what's going to happen to my squared when I integrate?
1/3 x cubed.
Or if you'd rather put the 3 under the x cube, you can. In fact, sometimes in this process, having that cube on top of the 3 means you already got your fraction. You don't need to change it, but I mean, just saying, that's something, if you're going to plug the number in for it, go ahead and just slip it up under there. It'll be fine. It works better for the math. So now we're going to plug in 2 first. Whoop. Minus 2 cubed over 3, minus putting in negative 2, 3. And when we get done with all of that math, we're going to multiply it by a 4th, and we're not even looking at the other side yet. Well, when we were doing it earlier, y'all, didn't I take what was b minus a every time I could and divide it into the other side? Okay, I'll go back. Hold on. Go back to this first example. It's more obvious. Okay, when I integrated this problem, I told you this 48 stood for the area under the curve, correct? And then I divided that 3 over here, and I got this 16. That 16 is the height of that rectangle, because that 3 is the width. We talked about that, right? Okay. So what I'm about to do here is to help me to figure out, all this inside is going to find the area. I'm going to multiply it by 1/4, and it's going to tell me the length of that, how tall it is in that rectangle, or width. The width is 4. We're just trying to figure out what the whole area is right now. So 4 times 2 is 8, minus 8 over 3. 4 times negative 2 is negative 8. This will be negative 8 to the, when you cube it, and that negative there will make it positive 8/3. Did I lose anybody there? We okay with that? Because I can distribute that negative now. Maybe, I don't know what will happen. I don't know if someone will drop out, or it just means I can add some stuff together. So if I distribute this negative, this will become a positive, and this will now be a negative. So I've got 8 and 8 are both positive, which is 16. And I got negative 8/3, and negative 8/3 is negative 16/3. Does everybody see that? There's an easy way to add it up. So I can either subtract that, or I can divide them both by 4 first. It doesn't really matter. Although I have to say, in this case, dividing each one of these by 4 first makes the problems a lot smaller for me to visualize the math. But you could put them together first and then visualize it. If you have the whole number 4 minus 4/3, because all I did was divide the tops by 4, isn't that the same thing as 4 minus 1 1/3? So that's just going to be 2 2/3. How I know is this is 12/3 minus 4/3, which is 8/3, which is 2 2/3, right? Now I want the 8/3. But I could have done it as mixed numbers and turned it back to 8/3. It's up to you. Now, I've got to set that. But let's talk about it again. What does this number mean in relation?
Or no, it's the height.
It's the height, because we've already multiplied the 1/4 through. If I'd have got these two together first, the 16 minus 16 over 3, that would have been the area. When I divide it by the width 4, it gives me the height of my figure. So now we've got to figure out, when is 8/3 going to be equal to 4 minus c squared? Because that c value is the one that causes it to find that equilibrium where the part of the rectangle that's missing meets in the same criteria as the one that's hanging outside. And that's not a very nice number. Would you agree? I think I'll multiply the whole thing by 3. Why would I want to do that? Yeah, I don't like fractions when I'm trying to work a math problem. I think it'll be easier to work it if it doesn't have a fraction in it. Because then I can take 12 away, right? It's easy to take 12 from 8. It's not easy to take 4 from 8/3. So 12 from 8 is going to be negative 4. Then we'll divide negative 3 into negative 4 and get 4/3, positive. And then we'll square root it, which will be 2 over the square root of 3. Plus or minus, right? Now, that needs rationalizing. So plus or minus 2 square roots of 3 over 3 is my c value. I also could turn it to a decimal value, in case the multiple choice answers on the test were decimals. But that was the easier one to get an exact to, so I thought it wouldn't hurt to look at an exact answer. Now, do you feel like that's not that much different than what we did on the other one? It's just the formula's written in a different format. They went ahead and put that number I was going to divide to the other side anyway. They just went ahead and put it on that side to get started. Is 1 enough on that? Because it's the same thing, isn't it? I mean, think about it. I forgot that